artificial intelligence. Yeah, thank you. So yesterday we have seen, the overview of artificial intelligence and how generative AI is different from the other subfields like machine learning, deep learning, right? So today, as I said, we'll be starting with the concept of deep learning. All right. So, based on yesterday's class, if somebody has a good knowledge or if somebody understood what is the meaning of deep learning, could you please answer this? Like, what is this deep learning and what it deals about? Yes, correct, correct. It's not like replacing the human brain. It is about replicating the functioning of human brain. Okay. Yeah, that is obviously correct. Thank you. I can't see who is talking because there is power off at my side and I did not link it to my other monitor. All right. So please don't mind if I'm not addressing your names. Yeah. So let us start this session. So we have that basic understanding, right? What is deep learning is all about. And firstly, I would like to introduce myself because I see some new names here, right? So this is Naveen, and I have been graduated from NIT Trichy, and I have overall 8.5 years of experience. And currently, I'm working as a AI specialist, and I'll be your trainer for this generative AI course. All right. And about this skill set required for generative AI, we will again look about it at the end of the session. Okay. Yeah. For now, let us start with the deep learning and let us have the overview of it in the coming 2 to 3 slides, the history of deep learning and the applications of deep learning, and slowly we will dive deeper into this concept. All right. Yeah. So if I ask you the applications of deep learning, yesterday also I have discussed about it, right? So if we talk about the real world applications of deep learning, so image recognition, natural language processing, speech recognition, predictive analytics, autonomous vehicles, all these things we have already seen, right? But to tell you specifically or to just give you the importance of deep learning in today's world, I would say many other applications, right? So for example, the face recognition you are used in unlocking smartphones or security surveillance, or even in airport immigration they'll be checking, right? So there, and voice assistants like Siri, Alexa, Google Assistant, which can understand, transcribe, and responds to your natural speech, right? So there we are using a deep learning and image recognition and object detection. So this is not only these AI subfields or AI concepts are not only limited to the IT industry itself, because we are seeing that these concepts are emerging and penetrating into almost all of the industries like health, etc., etc. And what I'm saying now is all about image recognition and object detection, right? So whatever we have, medical imaging, like x-rays and MRIs, here also we are using the deep learning technologies. Okay. And I said about autonomous vehicles, right? The self-driving cars. Okay. And even the it enables the vehicles to detect the pedestrians, traffic signs, and other vehicles, right? So those are all, you know will be coming under the deep learning, and even its applications are not limited to whatever I mentioned here, like I told you 9 to 10 applications, right? If we want to take some other, the recommendation systems or fraud detection, or natural language processing, where Google translation, language translations, or sentiment analysis, etc., etc., all these are applications of deep learning itself. Okay. Deep learning has been advancing, and you'll see that. So it started from RNN in the 1960s, and then LSTM, I mean, I'm telling about the text related. Okay. After that, transformers. So this is how the deep learning is progressing. So this is the applications of deep learning. Why I kept this slide over here is just to create that interest. So when you know that applications of deep learning, you will understand how important this concept is and how advancing this concept. All right, that's the reason even before telling the definition of deep learning, I have kept the applications. And yeah, so this we have already discussed yesterday, understanding the AI ecosystem, right? So you already know what this artificial intelligence is. This is the broader field and all the other or subfields of artificial intelligence, right? So if you want me to tell this quickly, what this is all about, artificial intelligence is like any machine mimicking human intelligence, right? So we have many machines or artificial algorithms or models which are trying to mimic human nature. In terms of intelligence, they are being equal to human intelligence or even surpassing it, right? So that is nothing but your artificial intelligence. Okay. And then machine learning. So machine learning is something that AI, learn from data, and once it learns from the data, it identifies the patterns in it and starts working on the task, allotted to it. Okay, from whatever the data it has learned, it will identify the patterns and then work on based on those patterns. That is nothing but your machine learning. You are making a machine to learn first and do the task later. So that is machine learning. And now the important at least for this class, which is deep learning, right? So deep learning, as someone answered, deep learning is nothing but, this is also field of machine learning, and in a broader way I could say this is a subfield of artificial intelligence that uses multi-layered neural networks. Okay, you will find the meaning of neural networks in the coming slides, but for now, based on the applications knowledge that you have, all those applications will be working based on the neural networks itself. Okay, that we'll be learning in the next slides. And then generative AI, you already know about this. This is a subfield again, which is majorly used for creating the content, right? So it might be text, image, audio, video, etc. And of course its applications are not limited to those four only. We have many other applications which we already discussed. Okay. Yeah. And on the right side you can see, I'm he's the godfather of deep learning. Okay, Geoffrey Hinton. And he was awarded Nobel Prize very recently. Okay, so he is a person who researched well on deep learning, and he made it practical and more famous in the real world. Okay, so if you are using those iPhones with Siri, we have been using that Siri voice assistant from around 15 to 20 years, right? So those applications were also part of deep learning. And when Everest Hinton introduced this deep learning, and it took some advancements, that was one of the first applications our industries have built. Okay, it might be Siri, Google Photos, or even Alexa. Okay, those were the first major applications of deep learning. Yeah. Now, so this is the question. So I was telling you, right? So whenever I go into the concept, I want you to know the history of it. So I just keep two slides of it. Okay. So that you'll have a very good understanding, and the understanding from the beginning of that concept itself. Okay, here we can see two researchers, and you can see their names over here. And they first thought whether we can create a machine or an algorithm which can think like a human brain, or which can work like a, human brain cell. Okay, so that was the concept these people have got those days. Okay, in 1940s itself. So from this point itself you can understand that deep learning, whatever the artificial intelligence concept we have here, it is nothing but an inspiration from human brain. All right. So it is an inspiration of human brain, and it all started in 1940s, and it has taken significant leaps afterwards. And this is the history of neural networks, and it starts from here. These are just the major milestones. Okay, but what I would like to mention over here is this thing in 2016. there is an algorithm called as AlphaGo. It was introduced by Google DeepMind. Okay, this algorithm was able to defeat the world champion, okay, in the game of Go. So if you do not know what this game of Go is all about, it is nothing but it looks like chess. Okay, so if chess has say lakhs of permutations and combinations for making a move, Go will be having a little more than that. So that was the major milestone and historical moment of this world. It created history, right? So an algorithm is defeating a world champion is a very big thing, right? So this happened in 2016, and all these were possible because of these neural networks only. Yeah. Now comes the part, what is this deep learning is all about. Okay, so deep learning, as you already know, is a subset of machine learning and artificial intelligence that uses multi-layered neural networks to model and understand complex patterns in large data sets. Okay, so for this moment you can keep these things aside. Okay, you please get this understanding, like it is inspired by the structure and functioning of the human brain. Okay, and then it involves networks with multiple layers, often referred to as deep neural networks, that automatically extract and learn hierarchical representations of data. So for now you just keep a note of it. I'm not going to discuss this now, because when you go deeper into this neural network you will be understanding what this hierarchical representations of data means. Okay, and here on the on the left side, this is a one second, did I mention labeled it? No. So this is a human brain. Okay, so if you do not know this, our brain is made up of billions of neurons or nerve cells. Okay, each of the nerve cell is connected with each other and they pass information from one entity to the other. Okay, so I have kept one such nerve cell over here. Okay, so this is nothing but a single nerve cell. On the extreme left side you can see dendrites. Okay, these are nothing but your input values, or this is a layer which takes up the input. Okay, this might be for example I am talking to you right now, and multiple processings are happening inside my brain now at the moment. Multiple calculations to deliver the speech in a sequential manner. Some kind of calculations will be happening inside, right? Or gathering of knowledge, or converting that into text, or into the words. So all those kind of calculations are happening, right? So this is the input we might be getting from some other nerve cell, and there is cell body. So this is a second layer which is called as soma, where actual processing will be happening. Okay, when I say the processing you'll understand it later, but this is the core part of this entire nerve cell. This is the core part. Okay. So now we have understood the first one and second one. So the first one is all about the input layer, and whatever the inputs are received at this point, they will be processed, and then you find the synaptic terminals at the end, which are nothing but the output generation layers. Okay, so input we are getting here, and then it is processing, and multiple calculations are happening over here, and whatever the calculation output it is generated, it is coming over here. So this is the output layer which delivers the output to the other nerve cell. Okay, so this is also a network. Why? Because each of the nerve cells are connected with each other, and billions of nerve cells are present in a human brain, and they are connected with each other. So that is the reason we are calling this as network, and this is happening naturally, so we can call it as natural network. And again, this is a nerve cell or neural cell, so this can be called as natural neural network. And I was telling you, right? So our scientists main aim was to create this type of network in a artificial manner. Okay, So this is how they built. And I have labeled it here, right? So this is the input layer where this receives the input, and then this is the hidden layer where the actual processing will be happening on the whatever the inputs you got. Okay. And then finally you can see the output layer which delivers the output. So if this is called as natural neural network, okay, this can be called as artificial neural network, right? Why? Because this is a artificial algorithm, and this is an artificial sorry, I got some disturbance. Second. Yeah. So this is a artificial, we can call it as artificial neural network, right? Which resembles exactly like a human brain nerve cell, right? So here also all these type of networks are connected with each other. Okay, here we can see only one hidden layer, but in general you will see thousands or hundreds of hidden layers in between. Depending on the application, we will be having number of hidden layers in between. Okay. And coming to this one, here also the same thing. Here also billions of nerve cells are present, and they're all connected with each other. That is the reason we are calling everything as a network. Here also the same thing. So I need not to explain these things. But this part I did not explain, right? Just as the brain uses neurons and synapses to transmit signals, okay, artificial neural network uses nodes and weights to process information and learn patterns. Okay, at this point of time you may not know what a node is and what are the weights. Okay, just to tell you, whatever the green ones traveling from this node to the other one, those are nothing but the weights. Okay, and these large ones are nothing but your nodes. So these are hidden nodes, input nodes, hidden nodes, and output nodes. Okay. Yeah. Hope you got some good idea about this, because this is what we are going to discuss a lot in deep learning. Now, I was saying this, right? So we have input layer, we have processing layer or the core part of the neural network, and we have the output layer. Correct? These are the three layers we have here. But here we have three nodes, but we have at this point we have two nodes and one hidden node and one output node, right? So to just give you a brief idea about neural network, I placed this, and this is called a single neural network. Okay, there is a name for this because we are using a single hidden node over here. Okay, I was telling you, right? So from input to the output, some of small dots were traveling. Those are nothing but your weights. Okay, usually they won't travel, but just for representation I kept like that. Okay, from this slide you just take this point, like these are the three nodes available in a neural network. Then see, this is a single neural network, right? But you would have already got this doubt. So a neural network is looking very simply. So is it able to create those wonderful applications in the real world? Means, I kept only one layer of hidden layer there, but as I said earlier, we might be having hundreds and thousands of hidden layers in between the input layer and the output layer. So as we go deeper and adding up lots of hidden layers in between, that is nothing but going deep, right? So it can be termed as a deep neural network. Okay, so this is not a shallow neural network which contains only very few amount of hidden layers in between. But if you have hundreds and thousands of hidden layers in between, that is called as your deep neural network. And the study of this deep neural network is nothing but your deep learning. All of the applications that we have seen, right, the speech recognition or self-driving cars, etc., etc., image recognition, etc., etc., are part of your neural network only. But they'll be having thousands of neural hidden layers in between. That is the reason we are calling it as deep neural network. And the study of this deep neural network and the functioning of it is nothing but your deep learning. Yes. So now it is the time for us to actually enter into the concept. All right. One second. Let me have a sip of water. So, so this is a simple example I kept for you to have a good idea of how the neural network will work. Okay, so let's assume this as yourself, and we are going to office daily, right? We commute, and most of the times we'll have to cross the road, right? So from going from one part of one lane to the other. Okay, so while crossing this road, what are the things, or before crossing the roads, what are the things comes into our mind? Whether is it a right time to cross the road or not? Okay, so this particular example I'll show you in the notepad itself, and or otherwise here I'll go to the next slide. So this is you. Okay, and at this point of time before you cross the road, you will be having some type of questions inside, right? Or we call it as intuition, right? So is the road clear? Like are you seeing any kind of vehicles approaching you towards this direction? Or the second one is, can you hear any cars? So there might be some people who are driving the car in the opposite direction as well, because we don't know, right? Some people usually violate the traffic rules, right? So these are the two questions we'll be having, and we'll look after these two questions, and then only we'll make a decision to cross this road. Am I right? And then I was telling you this inputs, right? So you should have got this input questions, or what this inputs is all about. So the first input is the road clear, and the second input is, are you hearing any car sound, like honking sound or engine sound, anything? Okay, and then we should understand what are these weights, right? Now weights are nothing but the importance that your brain assigns to each input. Okay, so let's say, is the road clear? This is a one input, right? How much importance you are going to provide for this particular input is nothing but your W1. And how much importance you are going to provide for this particular second input, which is nothing but your W2. Okay, so these are the corresponding weights. Hope you got idea on this. Now we'll go into the actual problem. Okay, so this is the example I have taken to make you understand the deep learning, a basic principle. Okay, so if you can understand this particular example, okay, I simplified this concept to make you understand through this example. Okay, so if you understand this particular example in a deeper way, so 25% of your deep learning syllabus is completed. Okay, even a little bit more than that, because whatever we discussed today, so the next classes will be advancements of that particular concept itself. Okay, why okay, I should not say activation functions or gradient descent, etc., etc. You may not be knowing that at this point of time, but yeah, you will come to know about it by the end of this class. Yeah, so this is the example, the neural network we have taken, right? So x1 x2 are the inputs. So x1 and x2 are the inputs, and then we have w1 and w2 as the weights, right? And then we have the output over here. Now we should understand what this hidden layer actually contains. That is our first question. And what is this bias? So this is our second question, right? So this bias is nothing but, at the moment, you can say that carefulness, extra care, we can say it as. Second. Yeah. So here we can say it as extra care that a person is taking, because not everyone will have a mindset, right? Even some people, even though some cars or vehicles are approaching towards him, he'll take the dare step to cross the road, right? If they are little bit far away from him, or even though they are nearer to him, he won't care about it. He'll try to cross the road. Okay, so that type of extra care that we are going to take is nothing but your bias in this particular example. Okay, we will understand what this bias is all about in the next class. Okay, for now you can keep it as the extra care that a person is going to take while crossing the road. And the next one I was saying, right, what this hidden layer and what actually contains inside, this is the next question. So hidden layer contains two major steps. Okay, so this is nothing but a processing, the calculation of the input and the weights is nothing but your processing, what I meant actually. Okay, and this delivers a output, so which comes over here. All right, so this thing, if you understand at this point, that is well and good. Now, so let's take anyone as an example here, and these are the inputs we have, right, x1 and x2. Now our question is that, so this is a human intuition whether you are going to cross the road now or not. So let's say we have this x1 value as 0, road is not clear. Okay, and even you heard some car sound, maybe engine sound or honking sound, right? Do you cross the road then? No, right? That's the reason you have 0. And then 0, road is not clear, and you did not hear any car sound, so it is 1. But you won't be crossing the road because the road was not clear, because a vehicle was approaching towards you and did not cross the road. And then road is clear, but you heard some car sound, then also few people or many of us will not cross the road because we feel that in the opposite direction some of the vehicles are approaching towards us. And the next one, road is clear and you're not hearing any kind of sound, then only we will cross this road. Okay, so that is the reason we have this output as 1. 0 is not crossing the road and 1 is crossing the road. This is nothing but your human intuition. Am I correct? Yeah. So now what we'll do is, we will replace this particular person from here, and we'll keep some model artificial more artificial intelligence, a robo or a model here at this point. Okay, now our main intention here is to get output of these values by an algorithm. Okay, which is nothing but your neural network calculation will make, and we'll make this artificial model algorithm or a robo in a simple way to cross the road or do not cross the road. Okay, so a robo must be able to take that decision, right? Now let us see how it is going to take that particular decision. So before that, we need to assume some of the values. We already have x1 and x2, right? We have x1 and x2, but we need w1 comma w2 and b. Am I right? And y is nothing but the output value that we are going to calculate. Now let us assume w1 equal to 1, w2 equal to 1, and b equal to minus 1.5, which means this person is taking very he is very much afraid of accidents. Okay, he's taking a lot of care. That is the reason we gave it as minus 1.5. Okay, Let's say these are assumed values. Okay. Now you should understand the second thing. What are these hidden layer letters sigma and f, right? Whatever we have here. Okay. In our mathematics, like in btech, or if you have done post graduation or even 10th class, sigma is nothing but sum, right? And f here is nothing but a function. Okay, so first we'll have to calculate the sum, and then we will have to apply the function over it. First calculate the sum, second apply function on it. So that is your second step, which is happening inside your hidden layer. All right, so based on this calculation only, you will be able to generate this output, and our robo will be able to answer this question whether it has to cross the road or not. So I'm just telling you, I'm mentioning a robo term over here just to make you understand it, what how we are going to progress. Okay, so you don't take that a robo is really going to cross this road or not. So this particular example is going to give you very good understanding on the neural network. So that's the reason I have taken this thing. All right. Now, firstly, before we calculate this processing or this kind of calculation, we have this general formula where z equal to w1 x1 plus w2 x2 plus b, which is nothing but your bias. This is nothing but your weighted sum. So if you calculate this, we would be completing the first step. Okay, now let us calculate on the basis of our values. Okay, we have x1 as 0 0, right? First, and second step is x1 equal to 0, x2 equal to 1, and third values are 1 0, fourth values are 1 1. So based on these particular examples, we will calculate. All right, so firstly x1 equal to 0 and x2 equal to 0. Now let us calculate the z, which is weighted sum. Now 1 into 0 plus 1 into 0 minus 1.5, it becomes minus 1.5, right? In the same way, we will have to calculate the next one. So here x2 equal to 0 and x2 equal to 1, right? So in the same manner, we will calculate it 1 into 0 plus 1 into 1 minus 1.5, which becomes 0. Sorry, minus 0.5. Yeah. And the third one, x1 equal to 1 and x2 equal to 0, right? So if you calculate those values, 1 into 1 plus 1 into 0 minus 1.5, which becomes minus zero point 0.5. And then we have x1 equal to 1 and x2 equal to 1, right? And if you calculate the weighted sum of it, 1 into 1 plus 1 into 1 um, minus 1.5, this becomes 0.5. Okay, now we got weighted sum for all of the values. All right, so we have calculated the weighted sum z. Okay, now the next step is to apply function over it. Sorry, I have a severe cold and fever, so I have to take a minute break. Sorry about it. So we have calculated this weighted sum, and now it's time for calculate applying the function over it. So this is the example we have taken, but we can give this simply in this way. All right, I have divided the steps like this: sigma and f. The first step as weighted sum and the second one as function, right? Right. So once we let me paste this somewhere else. Now we have calculated the weighted sums, right? First step is done. Weighted sum calculation is done. Now is the time for applying a function on it. So what kind of function we have to take? So for this particular linear problems or some kind of simple problems, we can apply the step function. Okay. So you don't worry what these functions are all. Okay, we will have a deep understanding in the coming slides. But in the coming classes, what are the step functions? What are the activation functions? And why these activation functions are? And how we are going to apply this activation function for problems like object detection or image recognition, etc., etc. Okay. So step function, how it used to look like, if you recall your btech or your graduation maths textbook, this is how it used to look like, right? If z is greater than or equal to 0, and the output becomes 0 if z is less than 0. Okay, so this is the step function. Okay, now we are going to apply this step function on the weighted sum we have calculated. Okay. So the first weighted sum we got is z equal to minus 1.5 for the values x1 equal to 0 and x2 equal to 0, right? And when you apply a step function on it, z equal to minus 1.5 means what is your value? It is coming as less than 0, right? So y equal to 0. This is your output, right? And then if x1 equal to 0, x2 equal to 1, then the z value we were getting is again 0. Now x1 equal to 1, x2 equal to 0. Then what is the weighted sum we were getting? Z equal to minus 0.5. Here also y equal to 0. So we got a positive value over here, and if you apply that z function over here, it becomes y equal to 1. So this is the output we have got. And we can successfully keep those values over here. Right now our algorithm has calculated and was able to generate the same values like our human intuition. So our artificial the robo or algorithm or model, whatever you kept here, it is able to cross the road successfully. Am I right? So if I want to represent these points in a graph, the first one point is there, right? X equal to 1, x equal to 1 and x2 equal to 1. If you plot those points, they will be coming like this is x equal to 1 and 1, and the other values over here. And we have a boundary like this. This boundary is nothing but the values that you have taken, the w and the w2, right? So what is our equation? Z equal to w1 x1 plus w2 x2 plus b. So addition boundary must be something which should not influence either to cross the road or not cross the road, right? That is the reason we are taking the output sum as 0, and we are entering those values. What is w1, w2 and b? Okay, 1 into x1 plus 1 into x2 minus 1.5. So this equation becomes x1 plus x2 minus 1.5 equal to 0. This is nothing but your line equation. Your line equation. So this is the line which got created over here, and it divides the points like this. So till now we had only four possibilities: x1 equal to 0, x2 equal to 0, x1 equal to 0, 1, 1, 0, and 1, 1, right? What if you have thousands of values like that? X1 equal to zero point 0.7, like car far away, zero point 0.6. So if you have thousands of values like that, are we going to calculate like this for each and every possibility we have? No, right? So if we have, and if we create a decision boundary like this, and your model is able to plot these points on top of this decision boundary and beneath this decision boundary, then it need not to calculate all these things, right? It can simply say, so beneath the boundary they are all do not cross the road, and above the boundary you can cross the road, right? So these kind of problems we have are nothing but your linearly separable problem. Okay, so this is the graph. If we plot all these points, so we have given only 14 possibilities. Okay, so this hope you understood. So zero point 0.9 car far away, and you heard a little bit of a car sound. Okay, zero point 0.8, zero point 0.7 is car far away, a little loud sound, safe to cross or not. So all this output is generated from, we can simply plot a graph, and we can simply say that above the line you can cross the road, and below the line you need not to cross the road, right? So these kind of problems are nothing but your linearly separable problems. Linearly separable. Okay, separable it is, SEPBLE. So if a student passed or not, if a student passed or failed, or student pass or fail, or whether to give the loan to a person, loan approval, whether to give a person loan or reject his application. Okay, or simple spam detections. Like this, or even your job application, whether it has to be rejected, or that application need to be sent to the further rounds. Okay, so all these of simple linearly separable things are nothing but your linearly separable problems. And the line which is over here, this is nothing but a decision boundary, because it is able to take the decision, right? Or it is able to divide the decision into two classes. This is your class 1, and this is your class 0. Okay, but When I said deep learning means the applications are like image recognition or speech analysis or self-driving cars, speech recognition I have already told you, right? Like a customer predictions, like whether he has given a positive review or not, it is called a sentiment analysis. But for you, to keep it simple, analysis etc, are we going to use the same linearly separable concept to this as well? Because this seems to be very easy, right? We just calculated the weighted sum and we applied a function over it, and we got some output, and based on this output we are able to say, we are able to take a decision, and this can be simply represented by a single line. So whatever is coming up on the line, we are able to say that class 1, so you are safe to cross the road, and whatever coming beneath it, under it, so these are not safe to cross the road. Okay, here also the same, like class 1 spam emails or non-spam emails, or job application passed, job application failed. So like that, where you'll have only two possibilities, you can simply apply the same concept of what we have applied over here and do such kind of tasks. But deep learning methodology is not limited to that itself. Okay, so we are saying that deep learning has applications on self-driving cars and all these, right? Even medical analysis, whether a person has a disease or not. So all these kind of applications, when a methodology needs to provide the result, then what are the things we have to change in this neural network is just the function what we are going to use. Okay, here we used only step function, right? Instead of this step function, if you use any activation function, then we will be converting, let me write it down. We can work on non-linearly separable problems as well, like speech recognition or whatever the applications or advanced applications I was telling, right? So to have these applications, we will have to use a separate type of functions called as activation functions. Okay, so if you use activation function instead of this simple step function we have used earlier in this particular example, we were able to solve some kind of non-linearly separable problems as well. Okay, so for this moment you can say almost all of the applications I was mentioning on deep learning will be coming under the non-linearly separable problems only. Why? Because your data is not that much easier to understand. Okay, when we say the speech recognition, your model has to understand the speech, right? It has to divide the words, and it has to allocate the words in a different regions. Okay, so to understand all these a sequence, a model must be having some type of functions inside. They are called as the activation functions. So we will have a thorough discussion on these activation functions in the coming classes. But for now, you can have a you know you can note it down. So these activation functions and all. So this you should have got this doubt. Being a generative AI engineer, am I going to calculate all this as part of my job? Am I right or wrong? So this is a general question people will be getting, right? So am I going to solve these mathematical problems if I get a job as a generative AI engineer, right? Actually, it is not. Why? Because we have dedicated frameworks for this, like TensorFlow, PyTorch, or Keras, which are called as deep learning frameworks. Okay, they are going to handle all these mathematical, heavy mathematical calculations inside. You just have to write a simple code importing those particular libraries, and you just have to provide the input values. Okay, so the inputs I have given, and I even provided the output as well. Okay, why? Because based on this output, your model will be knowing at first these let me open this. Yeah, at first we have these values, and these four values, and this is the output. And if I get some 14 million or 14 lakh problems or cases like this, so I'll have to generate the output based on this calculation happened in between these two, input and output. Okay, so they are going to take care of all those things. You need not to write or solve any kind of mathematical problems. Okay, and the activation functions I was saying, right? So the relu or sigmoid functions we'll be using. So this, in this simple problem, I have used those. Okay, so you need not to worry about this coding and all. We'll have a thorough discussion and sequential learning step by step. Okay, what I'm saying is, first we'll know this kind of libraries during the Python. Okay, Python learning, the advanced libraries like numpy, matplotlib, and pandas, how to import those libraries. And by going into the topics like this, by taking up some examples, we will have this outputs and inputs, why we have to give. Okay, and why these activation functions are, what are these optimizers, etc, etc. Okay, but this is the basic concept. We just have to have thorough understanding on these inputs, and how this processing layer is going to process and provide an output. Okay, and this is the output. And what is this bias? Okay, if you have good understanding on these things, your next topics are very much easier. We just have to change this function from this step function, a simple step function, to sigmoid, relu, leaky relu, or tana activation functions. Okay, for these kind of applications. This is bias actually. Yeah, bias actually, it keeps up. So, for example, you have the points x1 0 and x2 equal to 0. Okay, in that position, actually, what happens is that activation function needs to shift your model to understand the output, whether it is falling this side or whether it is falling this side. Okay, so if your values are 0 and 0 at that point of time, if all the values are 0 zeros only, if your model has only 0 0 0 zeros, okay, your output will be here only, but it is not able to generate any kind of output, right? So this is a intercept, right? The x1 plus x2 plus c, our line equation it is. Yeah, in this simple example, you cannot understand the meaning of a bias. Okay, so bias main aim is to shift the output. Okay, it gives the model flexibility. Okay, so in this simple example, we cannot say why, because when we apply these activation functions, those lines won't be linear. Okay, those lines will be curved or arbitrary shapes. Okay, so at that point of time, you can understand the meaning of this bias very easily. Okay, so we'll have, what is bias, we have a separate slide for that. So these are linearly separable things. So this is the one we are saying, right? But not all the times we have problems like this. We might have this as well. But here we are not going to divide the data based on a single line. We are not going to divide the data into two classes. So in this type of scenarios, we must be using activation functions, and that particular time you will be understanding what this bias is in depth. Okay, for that I'll have to introduce the activation function, what is happening, and the effect of bias on the hidden layers first. So there are multiple steps to understand it. Yes, yes, correct. Hmm. Yeah. Hmm. Yes, yes, these are different possibilities. I'm saying. Let me open this. There is one person. Okay, so today this is the first day. Okay, so he is going to cross the road. Okay, so the road is not clear and car horn was heard. So these are the two things comes into his mind at this point of time. So what he'll decide is zero. And the same person after 5 minutes, he'll check the road once again, right? So he at this point of time the road is not clear, and he is hearing this voice, car sound. No car sound. At that time he won't be crossing the road because these are the same person but different times. Okay, so not at the same point of time we are taking these cases. Okay, so the same person at let's say 10 o'clock, that person need to cross the road, and this is the inputs he'll have. At 10:05 he wants to cross that, he was waiting till all the vehicles move, and he decided to cross the road. Then also he'll think. So these are the inputs we will be having. And 10:10, the same person, he don't again want to cross the road, right? His aim is to go, aim is to cross the road, right? So this is the third scenario. And fourth, the same person in different times and different scenarios. This example is all about. And this is also same, right? You were saying 0 and 1, right? These are the possibilities of a person either to cross the road or not, right? The x1 value can be zero point 0.9 as well. Okay, because the car was far away, and he heard a slight car sound, that is the reason zero point 0.9. So based on these values as well, we should have an output. So these are the same person but we in different times and different scenarios. Let's say here 14 days. So if he is going 14 days to office every day, so this is the first day, 14. Or in other case, at 9 o'clock he decided to cross the road. This is the thing he came into, that came into his mind, the input values. And 9:05, these are the input values and output he has taken. 9:10, like that. Yes, actually, we will having this optimization methods. We can't simply assume the values as of w equal to 1, w1 equal to 1, and w2 equal to 1, and bias as this. We will have to follow certain methods for this, for assuming these values as well. Okay, so when we discuss about those optimization methods, we'll be able to understand why and what value we'll have to take for bias. Because these are assumptions, right? Who am I to assume these values? There might be people who gives less importance to these values as well. There is someone, if he sees a car a little bit far away, so he'll be that the visual carefulness, he'll be giving lesser value to this. He won't give much importance to it. And w2 also, Some people see, let's say you have a electric car, okay. An electric car is coming towards your way. So are you going to give you won't be considering any kind of importance to it, right? Because you obviously have to give importance, because the car doesn't make any kind of sound, and you cannot simply depend on the visibility weight over here. So for assuming these values also, we will have to follow some kind of instructions or methodologies. All right. So we can't simply assume this just like that. Just to make you understand the concept, I have assumed that in that way. So any other questions? So this is a sequence, right? Mm, this thing I was telling you, right? Image recognition. Deep learning sees this. For example, you have provided a dog image to your model, a dog, cat, elephant, and some other images of animals. Okay, in the first hidden layer, it is going to fetch some kind of basic information, like the color of it, I mean the pixel values, etc., etc. Okay, and in the second, it is going to decide the curve. Okay, what is the ear shape it is having. The second hidden layer it is going to take, and the third one, it will be taking up the complex nature of this particular object. Okay, so it is having a tail and it has this kind of particular shape, so it is not a bird, it must be an animal, right? So this kind of information it is going to take in the subsequent layer. So these are the hidden layers, and what are going to happen in the hidden layers is this particular representation I was telling, right? The hierarchical representations of data. So when this first layer has some particular information, that particular information will be passed on to the next layer, and this layer will be having the information of the first layer, and it will generate on its own. So like that, in a hierarchical and a sequential way, it is going to build up knowledge in identifying this particular object. That is nothing but your hierarchical. So it is going to take output of each and every layer and is going to proceed further. All right, so this is how deep learning uses the object detection. And yeah. And slowly we will progress into and or gates and decision boundaries, the importance of it, right? And activation functions, where we'll have a thorough knowledge on why we need this. Is a simple neural network model that we have explained in
Yes.
this particular session. But how the neural network model should look for this non-linearly separable problems, right? That also we'll have to discuss. Our main aim is to convert these kind of things into like this in a region space. Yes, you are saying something. Sorry. Do you have any other questions or?
Naveen, I have one question here. So you have discussed about the step functions, right? So which scenarios will be using this step function?
Yes, yes, it is. It is going to start 9 o'clock, 9 p.m. IST to 10 o'clock. So this is the second day. Yeah, we had a little bit knowledge on this deep learning yesterday. Okay, by this deep learning and what is the difference between machine learning and deep learning, etc. All those things. Yeah, introduction on deep learning. Yeah, there was a question. Sorry, someone has asked. Yes, yes. Yes, yes, yes. Yesterday I forgot to cover this part. So I would like to introduce person Banu. Are you there, Mr. Banu? So he is going to start Python. Okay, so I was saying, right, we are going to, no prior knowledge is required. So he is going to start with Python. Banu, Vasant Banu, if you did not hear this name in this institute or anywhere, he's currently working as a AI product manager in Gartner. Okay, so the Gartner is nothing but the job related and reviews related. It is more the company is all about. It's a very huge company, and he's working there as a AI product manager. So he took up many batches for this Python and machine learning actually. So here he is going to teach Python, and the classes are going to start from this Monday. All right, and all the other concepts coming from machine learning basics and the generative AI, etc., is part of my syllabus.
Negative situation to put is a desired effect.
Sorry,
Negative situation.
sorry, I did not hear.
Naveen, I have one question here.
Yes, yes.
Starting at కూర బాగుంది చూడండి.
One
బిర్యానీ బాగా
second,
చేసింది.
please. One second. I see I'm getting two voice. One second.
వయసు పాస్ అయినందుకు కాజు కత్తిరి తీసుకొచ్చి ఇచ్చింది.
Uh, yeah, yeah. Please tell me.
ఇప్పుడే ఓవర్లో వేయకండి ఇప్పుడు బిర్యానీ చేసింది వేస్ట్ అవుతాయి. మళ్ళీ ఆనందం ఎందుకు అదే బల్బ్ అంటే వానికి మీరు చెప్పారంటే రేపు మామ ఆర్డర్ చేస్తాను.
Yes, 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 yes. You can go ahead now. Yeah, yeah. Please. Sorry. Can you please repeat the question?
సరిగ్గా లేవు.
So I just wanted to know, like, in which scenarios the step functions will be used.
ఎంత పడింది ఇక ఫ్రెష్ అయ్యాను రా ఇద్దరు కొంచెం కాళ్ళు చేస్తాను మొహాలు కూడా నడుచుకోండి
Yes, yes, yes.
ఎక్కడ కొనుక్కున్నారు?
కొన్ని డిమార్ట్ కొన్ని డెనిమ్
Yes, yes. Correct.
టీజర్ డెనిమ్ అప్పుడు ఆ రోజు వెళ్ళాలి బ్లూ కలర్ లో ఉంటుంది షాప్
కొత్తపేట ఎక్కడైనా
Could you please mute yourself? Somebody is speaking, and I'm not able to understand the question. Whoever is speaking, could you please go on mute? Yeah, yeah, please. So you are asking about the difference between machine learning, the previous models and the current generative AI models, right? So that particular thing comes as the difference between machine learning and deep learning actually. So what this machine learning is all about, and what kind of algorithms we usually use in machine learning, and what kind of algorithms or neural networks that we are going to use in deep learning. So generative AI, when we study about generative AI, we won't be studying more about machine learning models, which are called as conventional models, right? Where human intervention is more, because you'll have to provide the data, and you'll have to label the data, right? And you'll have to manually provide some kind of features, so feature extractions, etc., etc., we have to provide. However, in deep learning, right, the almost all of the generative AI models, coming to the LLMs as well, right? So they are all dependent on the deep learning only, where the human intervention is very less, right? For example, if we have this spam emails and non-spam emails, right? How do we recognize which are spam emails and which are not spam emails? So based on some type of words, like congratulations, click on this link, or from the spelling mistakes, etc., etc. So these kind of values, the machine learning algorithms will be taking up, I mean, we have to provide them, right? And machine learning algorithms will be taking up those features, and will be identifying which of the mails are spam and which are the non-spam emails. And when coming to the deep learning, you won't be proceeding with this particular step, feature providing the features. So you need not to tell the model that these are the words. So if you find these words in the emails, you identify them as spam emails, and keep them aside. Okay, you won't be saying that, because you are feeding a lot of data to it, right, initially itself, and it is able to identify the spam and non-spam emails in it, and it will provide the output. So there is a quite a lot of difference between machine learning models, the conventional algorithms we had, like knn, addition trees, etc., etc. And when coming to the generative AI models, which are dependent on the deep learning. Okay, So yeah, we have a very great difference between that. The main thing is that deep learning, feeding and training the model takes a lot of time, whereas machine learning, it won't be happening. Machine learning requires only small data, like the spam emails I was telling, right? So you give 15 words to it, and if you find an email with those 15 words, you identify that as a spam email, we'll be telling that. However, in deep learning, we'll be providing tons of data to it, and it automatically detects which is a spam and non-spam email. Yeah.
Okay. So Naveen, in your example, like in your sample example, like x1 and x2 are the input arguments which you have set, and the output is something like we are making a decision, right? That is only one decision we are making.
Yes, yes, correct.
So like in the step function, will it work only for one that binary classification, like yes or no, like which you have given example, spam?
Yes, yes. Step functions
Only
are
for
basically for that purpose only.
okay.
They will be. We won't be using step functions mostly, because linearly separable problems are those already the machine learning algorithms are doing perfectly, right? So when coming to the artificial intelligence, or particularly generative AI, we have multiple things, right? Apart from classification, so it might be regression methods or generation of new data, right? So all these kind of things will have to use different functions which are called as activation functions. So whenever you build a model there, we'll be using mostly sigmoid, relu, or tana. So each of them have different problems, but we'll have to pick whichever is more suitable for our application, and we'll have to use that.
Yeah. Okay. Thank you.
Yeah, somebody is asking a question, sorry, can you please repeat once again? So what is B here? B is bias, and why we are giving that as a minus 1.5. You will have a good understanding on that in the coming sessions, right? So here, this is a simple linearly separable problem that we discussed. However, the deep learning concept is completely dependent on this input layer, hidden layers, and output layers. Okay, so here you may not understand why the line is shifting from right side to the left side. If I say that, you cannot understand. Even at this point of time, I cannot explain what is the exact functioning of B.
Naveen, can we say B is a hyperparameter?
Hyperparameter, yes, obviously it is a parameter. And one second, so we have that particular thing somewhere. So when we have this weights and biases, right? So the weights are nothing but the parameters when we call about this LLM, where we see GPT 3.5 have this 175 billion parameters, etc., etc., right? So there we can say weights and biases as parameters, but hyperparameter has a different meaning altogether, right? So bias we cannot call it as a hyperparameter, but it is more like a learnable parameter that we usually train a model on. Okay, so we can call it as a normal parameter or a learnable parameter. I'm not sure about this hyperparameter, whether B is can be called that or not. Obviously 99% we cannot call that as a hyperparameter, just a learnable parameter it is. Uh, so did you get that clarification on this? If you not, basically whatever the weights and biases we first,, uh, assume, right? So these will be updated each and every time, reducing the error produced by the output at the end, right? So when we say about this hyperparameter, we'll have to provide that manually, and it will be fixed value, right? It will be hyperparameter is something which will be fixed, but here weights and bias are the parameters which will be updating each and every time, reducing the error that we get. All right, these are learning parameters which will be updating, so these cannot be called as the hyperparameters. Hope you got this now,
Yeah,
right?
yeah, I got it. So, means anyway, in future classes, I'll be getting more clear, I think.
Yes, 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 sure.
So something like loss function or something,
Ah, yes, exactly,
adjustment,
exactly,
some adjustment,
exactly.
something we need to do. Okay.
Yes, yes. So loss function, it calculates the loss, right? What is the predicted value and how much loss we are getting, that gradient descent, right? Finally, we'll have some amount of error. So based on that amount of error, we'll have to back propagate and fix these weights and biases, right? So that is the reason we are calling this as learnable parameters. Yeah,
Okay. Yeah, got
yeah,
it.
yeah. Any questions, please? Okay, I'm not sharing my screen. Hope you got the difference between hyperparameter and parameter, and what are these weights and biases, right? So these are nothing but the assumed values at first, and they'll be updated each and every time. Okay, at this point of time you might get confused, but this is enough for the basics of deep learning. Almost all the other concepts which will be coming up in the next sessions are completely dependent on this. Okay, yeah. So any other questions we have, or do we have any other questions on this particular concept, or anything? So the classes are going to commence from this Monday, or we'll announce it in our WhatsApp group, or you can also check this with the management. They'll be able to answer you. And we are going to start our course with Python. Okay. So this will be started by Mr. Vasant Banu, as I said, and he's also I'm working as a AI specialist, as I said, and he's AI product manager in Gartner. Yeah. So if you have any other questions, you can ask me, or we'll wind up the session.
Tomorrow also we have a demo session or
Yes, yes, yes. Tomorrow also we have the demo session at the same time, and then I'll be introducing you to the concept of natural language processing,
okay, okay, yeah, sure.
NLP. Yes. Yeah, thank you so much for your time, and also thanks for asking these questions, right? Maybe at some point of time I would have moved from one picture to the other, but ultimately by asking the questions, I think people have got a good clarity. Okay, since we have a limited amount of time, and explaining this main concept of deep learning is little bit challenging for me as well, right? But yeah, I hope your questions got clear, your doubts. Yeah, yeah, thank you so much. We'll see you tomorrow at the same time. Meanwhile, if you have any questions, you can just raise it with the management or in the group. Yeah, thank you.
Yeah, thank you.